All right, we're going to talk about 5.1 modeling data with quadratic equations. I know you've learned quadratic equations and parabola and all that, and you know what the graph of a quadratic should look like. But we are going to, being given points, we are going to fit those points to a quadratic equation, which that part is probably new. So let's just look. The graph of a quadratic equation is called a parabola. Again, that is hopefully nothing new for you guys. Look at my cursor here, but that is like a U shape down, or it could be a U shape up. If it's down, it's a negative. If it's up, it's a positive graph. We'll talk about that. Y equals ax squared plus bx plus c is the standard form of a quadratic equation. Definitely write that down. If you don't have that, I'm going to refer to that often. The ax squared being the quadratic term, the bx being the linear term, and then c being the constant term. And then the turning point in the parabola is called the vertex. So again, let's go look back at our U, that point where it turns and goes from a decreasing interval to an increasing interval, that is its vertex. Or vice versa, when it goes from an increasing interval to a decreasing interval, that's the vertex, aka the turning point. Axis of symmetry, it is the line that cuts the parabola in half. So we call, the parabola is U-shaped. We call it a U because it's symmetrical about the vertex, or in this case, the axis of symmetry, which we'll look at all those as well. Okay, determine whether the function is linear or quadratic, and then identify the quadratic, linear, and constant terms. So what you have to do here's our quadratic standard form, our quadratic equation. We're given y equals 2x plus 3 times x minus 4. Just by looking at it, you might say, oh, there's not a quadratic term, there's not an x squared, therefore it's linear. And you would be wrong if you thought that. What you have to do is first, you have to simplify the equation that you're given. So this 2x plus 3 times x minus 4, let's first simplify that. Okay, so once it's simplified, you can do 2x times x is 2x squared, 2x times negative 4, oops, that should be negative 8x. And then we do 3 times x is 3x, and 3 times negative 4 is negative 12. And then we can combine our like terms, and negative 8x and 3x, we can add together and get negative 5x. So 2x squared minus 5x minus 12 is our standard form equation. Now, because we have a quadratic term, all you need is that 2x squared. Because we have that, it is a quadratic function. Like I said, all that could be deleted, and that would still be a quadratic function. We could get rid of the 2. That's still a quadratic function. As long as you have that x squared in there, it's a quadratic function. And as long as the x squared is the biggest exponent. You're going to do a couple of those problems in class and on Edpuzzle. I'll have you do. Identify the vertex and axis of symmetry of each parabola. Again, the vertex is the turning point, or in this case, where the decreasing interval changes to an increasing interval. So that would be right here. So the turning point is happening at 0, 0. So the vertex is at ordered pair 0, 0. Axis of symmetry is the line that cuts the parabola in half. Well, we've already talked about how this vertex, the turning point, it's the midpoint kind of your vertex. It's the half point. So the axis of symmetry is a vertical line going through your vertex. And because all vertical lines are created by x equals at that point is 0. So x equals 0 is our axis of symmetry there. And then for each parabola, we already talked about how, again, they are symmetrical about the axis of symmetry. So right here's our axis of symmetry. For each parabola, identify points corresponding to P and Q. So if I wasn't given this parabola and I was just told, hey, you have a quadratic equation, the vertex is at 0, 0, one point is at 2, 4, that would be point P, and another point is at negative 1, 1, and that point would be Q. Find its corresponding points. Again, because our quadratic equations are symmetrical, I know since P is 2 units away from my axis of symmetry, P prime, or its corresponding point, is also going to be 2 units away from the axis of symmetry. So we'll say P prime is -2, 4. Again, it's basically its reflection point on the y-axis in this case. Now, if this parabola was shifted over, it's not necessarily the reflection point on the y-axis. It'd be the reflection point on the x equals whatever the axis of symmetry is. So P prime, which is right here, will be at -2, 4. And then Q is at -1, 1. So Q prime, again, has to be the same distance away from the axis of symmetry. So Q prime is going to be at 1, 2. Because it's 1 unit away from the x-axis. 1, 1, not 1, 2. Last part. This is why we had to review solving systems of equations. 2 variable and then onto the 3 variable. We have to, given points, find a quadratic function that fits the data. A batter hits a fly ball. The table shows the height of the ball at different times. So here we go. Time is 2 seconds. After 2 seconds, the ball is 30 feet high. After 3 seconds, the ball is 40 feet high. And then after 4 seconds, the ball is now 32 feet. So at some point between 3 and 4, the ball starts to decrease or come down. So remember, ax squared plus bx plus c is our quadratic equation. Now notice I have it equals f of x. This is just function notation. If you remember, f of x and y are the same thing. This is just function notation. So basically, I'm trying to find the values for a, b, and c. So what I do is I take the points I'm given. For instance, when x is 2, so after 2 seconds has passed, the height is 30 feet. So when x is 2, y is 30. So I plug 2 in for my x. So I have a times 2 squared plus b times 2 plus c equals 30. And I do that for all of my x values. I need to do it for 3 separate ordered pairs. And since I'm only given 3 ordered pairs, I do it for a times 3 squared. So I do it for after 3 seconds, it equals 40 feet. And then after 4 seconds, it equals 32 feet. So I have all that here on the left-hand side. Then I simplify it. So let's look to the right. 2 squared is 4. So we have 4a plus 2b plus c equals 30. 3 squared is 9. So we have 9a plus 3b plus c equals 40. 4 squared is 16. So we have 16a plus 4b plus c equals 32. So there's that simplified. Now you might look and say, okay, what does this do? Guess what? It's our 3 variable system of equations here. So now we solve it just like we did lesson 3.6. Pick 2 of them. Looking at it, I think c is going to be the easiest variable to eliminate. So I picked the first and the second one, paired them together, and I multiplied the first one by -1. So I have -4a minus 2b minus c equals -30. Brought the second one down, added them up, got 5a plus b equals 10. Okay, well then I paired the first and the third one together. Again, I multiplied the first one by -1. The third one I added and got 12a plus 2b equals +2. So I then take those 2 equations and I set them up. I looked and I said, okay, I think b is going to be the easiest variable to eliminate. So I'm going to multiply this red equation by -2. So that's how I got -10a minus 2b equals -20. And then I add that with the green equation, since my b's will eliminate. And I get a positive 2a equals -18. Solve for a, we get a is -9. Which you might say, okay, so that's a negative graph, which means the parabola is going to open down. So it's going to be an upside down U, which makes sense. Because if I'm hitting a ball, it's going to turn like that. It's going to go up and then fall down. It's going to go from an increasing interval to a decreasing interval. So like this shape. Okay, so then just like I did with our solving systems, I take that -9, I plug it in for a in either one of my red or green equations. I chose red. So I did 5 times -9 plus b equals 10. 5 times -9 is -40. -45. Add 45 to both sides. I get b equals 55. Okay, so then I take, I think I plugged it into my first equation, the 4a plus 2b plus c equals 30. So I did 4 times -9 and got -36 plus 2 times b. Well, b is 55. So 55 plus times 2 is 110 plus c equals 30. -36 plus 110 is 74. subtract the 74 from both sides, and we get c equals negative 44. Now in this case, because I came up with those points, the data values to begin with, this doesn't really make sense because c would be our y-intercept or our starting point, and clearly I didn't start hitting the ball when I was negative 44 feet deep. So in that case, it's a little messed up because I created it. But we have, here's our quadratic equation. A is negative 9, so negative 9x squared. B is 55, so 55x. C is negative 44, so minus 44 equals f of x. So that's the quadratic function of a person hitting the ball and then at different times. If you have any questions, make sure you write them down, and we will talk about them in class. Thank you. Have a nice night.